Okay, so this question is asking you to compare several different functions to this function called function A. And just as a reminder, we can tell this is a function because every input value or x value has one output value that goes with it, not multiple output values. So this function A, um, it's a linear function, and so it has a constant rate of change or a slope and an initial value, or otherwise known as a y-intercept. And remember, to find the rate of change, you have to figure out how much does y change per one x change. And right now, in some places the table actually is going up by one. In other places the table is going up by other amounts, by two or by, I guess it's one or three. Um, so really, I looked at where x was 5 and y was 9.5, and then where x was 6 and where y was 11. And what I noticed was the x was going up by 1 at that point, and the y was going up by 1.5. And so what that means is that the rate of change is 1.5, or 3 over 2. And if you check the rate of change between other points on that table, you'll see that it ends up being the same thing. The initial value was given to us because the initial value is where x is 0, and so the initial value for this function is 0, comma 2. What you were asked to do at this point was to compare that function um, to four other functions and decide which function is the same as function A, which function has the same rate of change as function A but a different initial value, which function has the same initial value but a different rate of change, and which function has a greater rate of change than function A. And the first function that you were comparing it to was given in a description like this. So during a rainstorm, the water level in a kid-sized pool rises 1.5 inches every hour. Before the rain started, the pool had 1 inch of water in it. Well, this 1.5 inch every hour means that the water rises 1.5 inch for every 1 hour, which makes 1.5 the rate of change. And then it tells you that the pool had 1 inch of water in it to start with, and that 1 inch of water is the initial value. And so what I noticed was that the rate of change between this function 1 and function A was the same, but it has a different initial value. And so I chose that for function 1. Now here are these things again. Function 2 was this equation, y equals 1.5x plus 2. And I noticed that that equation is in y equals mx plus b form. And if you remember, y equals mx plus b form tells you the slope, because that's the m value, and it tells you the y-intercept, or the initial value. That's where the b is. And so this 2 is the initial value in this function, and the 1.5 is the rate of change, otherwise known as the slope. And so when I compared that to function A, I noticed that it's actually the exact same as function A. It has an initial value of 2 and a rate of change as 1.5, so this is the equation for that table. Function 3 was a graph, and so I had to look at it a little bit differently. I did notice right away that you can see the initial value pretty easily. The initial value is 2, which is the same initial value that function A had. To find the rate of change, remember I needed to find how much does y change when x increases by 1. And I saw that from this point to another point on the graph, x increased by 2. And then to stay on the line, y had to increase by 1. And so if y increased by 1 when x increased by 2, then it means the rate of change would be 1 divided by 2, or 0.5. And so that function has the same initial value as function A, but a different rate of change. It's that third choice. There is only one left for this fourth choice, but let's take a look at it. So the function 4 was a table. And if you notice, the initial value on this table is 0. And so already I know that this does not have the same initial value as our function A. And then to figure out the rate of change, I looked and saw that on this table, x is constantly increasing by 2. And as x increases by 2, y increases by 4, which means to find the actual rate of change for when x increases by 1, I have to do 4 divided by 2. So that makes the rate of change 2. And if you remember, function A had a rate of change of 1.5. And so that means that this function 4 is a function with a greater rate of change than function A.